This video has 3 parts. In part 1, we'll solve a math problem. In part 2, we'll solve USACO Bronze Part First Contest December 2023 problem number 3. And in part 3, I leave homework. And if you want to learn background ideas of USACO or USAMO, AMI, AMC, important ideas in combinatorics, algebra, number theory, and geometry, algorithm, feel free to send message to my WhatsApp number in the description. Part 1. A to the A is A to the 2024. So, for this problem, we know A is not 0. Why? Because 0 to the 0 is undefined. So, A, we can conclude that it's not 0. Now, if we divide both sides by A to the 2024, we have what? A to the A minus 2024 equals 1. Now when something to the power of something is 1, let me tell you here, ideal 1. If x to the y equals 1, what are the cases? X can be 1, one case. Second case, y is 0, but x is not 0. And third case, x is negative 1, and y is, we can say 2k over here, for example. If we consider in the simplest form, it will be, for example, 2m plus 1. Okay, if we consider first case, x equals 1. X is what here? A. A is 1. So one answer is A1, and you will see A1 to the 1 is 1 to the 2024. Both sides will be 1. Second case. Y should be 0. Power should be 0. A minus 2024 should be 0. And base shouldn't be 0. A shouldn't be 0. So let's check. In this case, A equals 2024 and A is not 0. Second answer. And let's check 2024 to the 2024. Right side also is same. Third case, X is negative 1. Base is negative 1. A and power should be even over odd. So if you check both power, A minus 2024 is 1, negative 1 minus 2024. Which is negative 2025, and the power, if you consider it, it will be odd over 1. And it's bad. Why? Because it will be negative 1 to the negative 2025, which is negative 1, and it's not good. So we found 2 answers for this problem. A is 1 and A is 2024. If you want to learn, as I said, more background ideas, feel free to send message to my WhatsApp number in the description. So, next part, this USACO bronze problem. Pause the video and read this problem completely first on your own. Okay, let me explain this problem. First, it says we have 6 test cases. This one 1, 10, 1, 0. This is for our first test case. Let's consider this case first to explain. I can explain better problem here. It says 2 means we have 2 numbers, 7, 3. It says in each step we add 7 by 8 and we add 3 by 10. We add 10 to 3 each time. And then we reach new numbers. So we have what? In first step we have 7, 3. In next step 7 plus 8, 15. 3 plus 10, 13. In next step this plus 8, 23. This plus 10, 23. In next case this plus 8 is 31. In this next case this plus 10, 33. This plus 8, 39. This plus 10, 43, and so on. But it says what? When it says 1, it means one number should be greater than first number. 0 number should be greater than this number in some level we want to reach the case. When one number should be greater than this, greater than the number here, means this number is smaller. So this part should be smaller than this part. So if we check 7 is greater than 3, 15 greater than 3, 23 greater than equal to 23. The first part that this one is smaller than this one is this case. So it is what? After how many steps? 1 step, 2 steps, 3 steps. We reach this, and this 3 is because of this point. Okay. So by this line, we can understand which one is greater. Now, if we consider first one, it says, okay, we have one number, 10, and each step you can add 1. This one should be, we have, because we have only one number, 0 numbers greater than this, so you don't need to add anything, so the answer is 0 for satisfying this order. Next part. Let me consider this. Okay. It says we have 7, 3. In each step you can add by 8, and this one you can add by 9. And this one number should be greater than this. This one 0 number greater than this, so this one should be smaller. This. So 7 plus 8 is what? 15. 3 plus 9, 12. 7 plus 15 plus 8, 20. Still, here we know that this one is greater, but we want to reach this. Here, this one is greater than this one. 23 plus 8 plus 9, 21 plus 8, 31 plus 9, 30 plus 8, 39 plus 9, 39. So greater. In next step, this one plus 8 is 47. This one plus 9, 48. This one is greater. After how many steps? So 1, 2, 3, 4, 5 steps. So let's check. If we check here, we will have, when I wanted to paste the solution here, 1, 2, 3, 4, 5 test cases, but here it's 6. So I forgot to consider this. So this 5 is the answer of this one, okay? Let's check this negative 1, 2, 7, 7. 8, we can add 8, we can add 8. And it says this one 0 greater than this, 1 greater than this, so this one should be smaller than this. And as you can see, always they are equal. So when it is not possible, you should print negative 1. Next one. 7, 3, 8, 8. You want that this one greater than this, so this one should be smaller. But always this one will be greater than this one, because in each step we add 8 to both of them. So again, negative 1. Let's consider another input-output. So this one, this part is important. I want to explain algorithm of this problem here. It says 2 test cases, 5, 7, 4, 1, 10, 12. 7, 4, 1, 10, 12. And 3, 4, 5, 2, 1. 3, so in each step you can add 3, you can add 4, you can add 5, you can add 2, you can add 1. And now it says which of them should be smallest. For this one, all of them should be greater than this. So this one is the smallest. I write 1, smallest, 3. This one after that is greater than that. 2, 3 here, 1, 4, and this one is the largest. When I want to solve this one, I sort these numbers with respect to these orange numbers, to the order that I want to reach. I consider this one as first one, this one as second one, this one as third one, this one as fourth one, this one as fifth one. Means the greatest one. Okay, now if I consider, I want to see, suppose after k step, this one should be less than this, less than this, less than this, less than this. So up to this part, when we sort, it will be order of n log n. And n is 2 times 10 to the 5. So n log n is okay. Now I consider these two numbers. It is what? It is 12 first number, and in each step we add 1. So after k is the step, after I want to consider, after k steps, suppose k is our answer. After k steps, this one should be less than 10 plus 2k. This one should be less than 7 plus 3k. Next one less than 4 plus 4k. Next one less than 1 plus 5k. And if you consider these two parts, if you simplify this inequality, if you subtract k from both sides, k greater. If you subtract 10 from both sides, 2. So k should be greater than 2, so k is at least 3. By considering first inequality, we have n minus 1 inequality, and I will show you how to check each part with order of 1. This one, k is greater than 3, so k is greater than equal 4, because k is integer. This one, 3k, 4k, if you subtract by 3k, and if you subtract by 4, it will be 3, so k is at least 4. And now this one, k greater than equal 5k minus 4k, k, 4 minus 1, strictly greater than 4 minus 1, 3, so k greater than equal 4. What is the minimum k that satisfies all these 4 inequalities? Greater than equal 4, greater than equal 4, greater than equal 4, greater than equal 3. So 4 is the minimum number that satisfies all these 4 inequalities. It is our 4. Let's check next example. And we write numbers. 4, in each step you can add what? You can add 3. 10, in each step you can add what? You can add 1. 12, in each step you can add 1. 7, in each step you can add 4. 1, in each step you can add 5. And the order. Which one is the smallest? This one, because 4 numbers are greater than this. 3. This one after that, after this. 3, 4, 5, greatest number. Now again, we sort these numbers with respect to their order. In the end, so 3, 4, 5. Now here, I consider what? So because there are T1, T2, when you want to sort, your condition is that if Ti, you want to sort such that Ti should be greater than Tj. Okay? So for example, this one, 0. Which one is greatest? Here, 4. So we consider this 10, 1 in the beginning. 3, this one, 10, 1. Okay? So 3 is 12, 1, third one, 12, 1 here. Okay, when you want to type the code, you can use this condition to sort them like this. Now, again, I want to write the conditions. Here, it will be 10 plus k. Suppose after k steps, we can satisfy all the conditions. So 10 plus 2k, 12 plus k, because 1 in each step, 4 plus 3k, 7 plus 4k, and 1 plus 5k. So if you simplify first condition, it's always correct because if you subtract k, 12 is always greater than 10. If you consider this one, so from here you can say k should be at least 0. K, here 3k, 2k. If you subtract k, it will be 2k. If you subtract 4 from both sides, 8. So k greater than 4. So k greater than equal 5 because k is integer. If you consider this one, if you subtract 3k here, k, if you subtract 7 from both sides, negative 3. So because k should be at least 0, we can write it as this one, 4k, 5k. K, we subtract 4k, and if you subtract 1, it will be 6. So k is at least 7. Now we should consider minimum k that satisfies all these inequalities. 7, 0, 5, 0. So it has to be at least 7 and minimum 1 is 7. And if you check our output, it will be 7. Okay, now let me completely explain algorithm. Now you can guess the algorithm is what. Let's work on that completely. Again, we sort numbers. Suppose A1 here. It says the heights are H1, A1. Let me check it again. The variables, okay, N, HI, AI. Okay, so we sort them, and how we consider H1, A1, H2, A2. We consider these things such that without loss of generality, such that the first one, T1, should be greater than when we sort. Our condition is what? T1 should be greater than T2. Sort like this. H3, A3, and HN, AN. So T2, T3, and TN. Exactly like the examples that we worked on. Now we should consider each case. For example, I know what, I know that. I will explain for H1 and H2, and you can write exactly for other conditions. Without loss of generality, suppose that we want to consider H1 plus A1K is less than or equal H2 plus A2K. Now we subtract A1K from both sides and H2, so it will be A2K minus A1K, and also we will subtract H2, H1 minus H2. Now I can write it, sorry, it's strictly less than and strictly less than. Then I factor from K, A2 minus A1. Now it's important that A2 minus A1 is positive or negative or 0. First case, A2, if A2 minus A1 is 0, you should check this case if we have this condition. Then we know right side should be 0 and left side is H1 minus H2. Let me write it here. H1 minus H2. And so H1 minus H2 less than 0. So it is equivalent that H1 should be less than H2. If we have H1 less than H2, we have what? Let's consider else. We know that it's wrong, so you should say it's impossible or print -1. But if H1 is less than H2, for each of them we will explain K. For example, K should be what? Here, K should be at least 0, our condition here. Now, so for this one, for example, you can define K1. For this one, K2 to Kn minus 1. Okay, so this K will be at least 0. Second one, if A2 minus A1 is positive, then we can divide both sides by A2 minus A1. A2 minus A1, and this sign won't change. Less than K. But K is integer. Maybe this number is real number. So if I want to say K is at least what, I can say that this number maybe is real number, so you can say ceiling of that, but maybe it's integer. So I can write floor of that plus 1 always. So if you have two integers here, if it is between them, floor of that will be here, then plus 1 will be here. It's okay from here. If we have integer, this one is greater than this one, floor of that will be this, plus 1 will be this, greater than equal this. Okay, so we found this. Now for last condition, if A2 minus A1 is negative. Third case, if A2 minus A1 is negative. If we divide both sides by A2 minus A1, sign will be switched. So H1 minus H2 over A2 minus A1 will be greater than K. So here again, if we consider two numbers, if it is D here, K should be less than or equal. If you consider floor of that, when we have integer, it's bad because K should be strictly less than that. So you can say K should be strictly less than ceiling of that. a2 minus a1 plus minus 1. Okay, so for this one, say if we round up, it will be this, then minus 1 here, less than or equal, it's correct. For this one, it will be this one minus 1 here, less than or equal this, it's correct. Okay, so for each case, we found that we can say k at least 0, k at least this, k less than or equal this. So for some cases, we have less than or equal. For some cases, we have greater than equal. So we have what for first one, for example, k1 less than or equal, k2 greater than or equal, k3 less than or equal, 2, for example, k and minus 1. For example, greater than equal. Now we have some upper bounds, some lower bounds. Okay? So for example, this one 0, this one, for example, 100, something like this. So we have some upper bounds, U1 to UR, and some lower bounds, L1 to LS. Upper bounds means what? Our K should be less than or equal U1. All of these conditions should be satisfied. So we can conclude K should be less than or equal minimum of them or maximum of them. Because all conditions should be satisfied, K should be less than or equal minimum of U1 to UR. For this part, K, they are lower bounds, greater than equal L1 to LS. Because we want that all conditions should be satisfied, K greater than equal maximum of L1 to LS. Now we have one thing. For example, it is a small m, it is big M. Or, yes. Or let's say this. We consider this one K mean and K max. Okay? Because here we should consider minimum of these numbers. It should be less than or equal this. Let's consider this one, the name of this, K max, K min. So we can find this minimum and maximum. Now, K should be what? Less than or equal K max, greater than or equal K min, and we should find minimum K. If K min is less than or equal K max, then we should print what? We should print K min because we should find minimum K. Else means what? K min is greater than K max, and that's a contradiction. So it's impossible, and we should print -1. Okay, so checking these things, the order of checking these things will be order of n. So first part, when we sort n log n plus order of n, so it will be order of n log n. Okay, if you had question or wanted to learn more important ideas here, we should check small cases, special cases, small examples. And I said in the videos I released before USACO 2023, it's so much important. If you want to learn other important background ideas, feel free to send message to my WhatsApp number in the description. Now let me tell you one homework. It is related to a recursive sequence problem. It is useful for math and also computer programming because recursive sequence in USACO or other Olympiad in informatics will be dynamic programming. So the problem is what? It says, suppose we have these things. We call this x0, y0, x1, y1, x2, y2, to last part we have this one is xn, yn and xn, and an is, let me move it here, we want to reach from x0 to yn. An is number of ways to reach from a0 x0 to yn, and we can't pass from a point more than once. We can't pass from a point more than once. Now, the problem wants what? Find recursive sequence for an. Okay, I can say it's a hard problem. And try to do this one as homework and comment your answers if you found. Comment your answers right below this video. Okay? And if you wanted, as I said before, if you wanted to solve more problems, as I said before, feel free to send message, my WhatsApp number in the description. If you wanted to learn 40, 50 important ideas and formulas in combinatorics, algebra, number theory, geometry, algorithm, and other topics. Thanks for watching this video. Bye.